Hello there, Algebra Lite students. Mr. Lawrence here, and this is kind of a strange thing we have to do. Actually, I am sitting in a hospital bed right now making up this video. I'm okay. Heart's acting a little bit funny, so the doctors wanted to look me over. So I can't be there with you today, but I'm going to be here with you through the use of this video. So David and Lily and Abby and Corinne. Corinne and Abby. I always get you two mixed up. I have no idea why. And Jasmine and Maura and let's see, Brandon and who am I missing? Oh my gosh, I can't even think of who I'm missing here. I apologize, Mackenzie and Anthony and Mason. Not trying to miss anybody on purpose, trying to get you all, but make sure that you're doing your best on this video, okay? I really need you to do your best because I can't be there for you. So I'm putting this video together at 7:15 on Sunday night. I'm bored off my keister, sitting in the hospital, waiting for them to, do whatever they got to do. I'm not going to get out till tomorrow, so I won't be able to be there. So I really need you to take good notes on this. It seems hard at first, but it really isn't. It's really algebra material, and I know you ladies and gentlemen are smart enough to handle it. So you take notes, you pause the video, you try the problems, and then when you're done, you can work on the homework, okay? And the homework will be on digits. I think 3, I think we're on. I think that's right. You'll have to check the homework. Anyway, okay, so here we go. So let's do a quick review. There it is. Wasn't working. I want you to solve for x. I got 3 problems. This is Thursdays and Fridays lessons. Solve for x. Go ahead and pause the video, write down these problems, and solve for x. Now, Mason, don't just write down the answer, right? Show the work. Okay. Whoa, little power surge there, crazy. All right, here comes my solution. If you haven't solved yet, you need to. You need to pause the video and then unpause it to see my solution. Here it comes. All right, I've got x squared equals 144. So the first thing I'm going to do is take the square root of both sides. And I remember Mr. Lawrence teaching me on Friday that when I take the square root of both sides, I'm going to get 2 answers, right? So I'm going to get x on the left-hand side, and the right-hand side I'm going to get plus or minus 12 because 12 squared is 144. It's always negative 12 squared. 12 times 12 is 144. So is negative 12 times negative 12. You could write your answer like this: x equals 12 or x equals negative 12. Either of those are good. Okay, this way or this way. I like this way. You may not. All right, B. How am I going to do B? Well, if you try to take the square root of 27, you're in for a rude awakening. 1, it's not what you should be doing at all. 2, 27 is not a perfect square. So if you take the square root of it, you're going to get an irrational decimal. Okay, so the first thing I'm going to do is I'm going to eliminate this multiplication. I'm going to do that by dividing. I'm going to divide both sides by 3, and I will end up with x squared equals 27 divided by 3. Better said is 9. And then I'll take the square root of both sides. And I remember Mr. Lawrence saying that when you take the square root of a number like that, when it's x squared equals a number, you'll get 2 answers. And I'm going to get x equals plus or minus 3. X will equal positive 3, x will equal negative 3. All right, finally, here's a cubed root one. I have x cubed equals 125. I need to take the cubed root of both sides. Now, I also remember Mr. Lawrence saying that when the power was odd, you don't get multiple answers. You only get 1. So in this case, x will equal 5. Why? Because 5 times 5 times 5 is 125. All right, so that's a quick review over what we did last week. Now, what happens when we have 5 times 5 times 5? Now, if you were paying attention to the last problem, you go, well, I know, Mr. Lawrence, I know it's 125. But I want to point out to you that we can think about 5 times 5 times 5 as 5 cubed, right? It'd be like 5 to the first, 5 to the first, 5 to the first. Hey, look at that. 1, 2, 3, 3. Wow, that's really interesting. Let's go down here to 5 squared times 5 to the first. Now, at this point, you shouldn't just be watching. You should be taking notes on this. If I'm going too fast, pause and then write down what you need to do. Now, some of you will struggle on 5 squared times 5 to the first, but what you got to realize is 5 squared is just 5 times 5 in disguise, isn't it? Right? times another 5. Hey, that's the problem we just did. That's 5 cubed, right? Hey, look at that, a 2 and a 1. 2 plus 1 is 3. 1 plus 1 plus 1 is 3. Huh, pretty cool if you ask me. Let's take a look at this one here. What's this one? I've got 2 to the 4th times 2 to the 2nd. Well, 2 to the 4th, wouldn't that mean 2 times 2 times 2 times 2? And then 2 to the 2nd means 2 times 2, right? Ali could tell me how many 2's are being multiplied, right? Noah would confirm it for me. There's 6 2's. Well, instead of saying 2 times 2 times 2 times 2 times 2 times 2, we could just say 2 to the 6th power, couldn't we? Isn't that right, Athena? Hey, look at that. 4 plus 2, 6. Dun, dun, dun. What I've just discovered, what we've just discovered, is that in multiplication, are you writing this down? In multiplication, are you writing this down? In multiplication, if the bases are the same, add the exponents. Right? If the bases are the same, add the exponents. So in other words, if I had to do, where's my marker? If I had to do, say, triangle to the 75th power times triangle to the 5th power, that would be the same as triangle to the 80th power. Where did I get 80 from? 75 plus 5. Why can I do that? Because the bases are the same. You see that? Yeah, it's real simple. If the bases are the same, 7 to the 8th times 7 to the 4th, that's the same as 7 to the 12th. Now, 7 to the 12th is a very large number. No, it is not 84 like some of you were thinking. This is an exponent, not multiplication, right? Okay, so let's go back and let's see if you can do some of these problems here. Let me scroll back down and let's see what you can do. Okay, there you go. There's one to try. You've got x to the 7th times x to the 4th. If the bases are the same, you can just add the exponents, all right? Go ahead and do that one. Here comes another one to try. X to the 5th times x cubed. And we're going to pause right there. All right, hopefully you've tried them in your notes. If you haven't, pause the video and get them down. Attempt them on your own. I see the bases are the same. Now, I have 7 x's here. Can you see the 7 x's? X to the 7th means this. 3, 4, 5, 6, 7 x's all being multiplied together, right? And here we have 4 more x's being multiplied, right? X times x times x times x. All together, don't we have 11 x's being multiplied? This is x to the 11th power. The shortcut is to go 7 plus 4 equals 11. This only works if the bases are the same. If the bases are different, you can't do it. All right, hopefully you've done this one by yourself. X to the 5th times x cubed. If you haven't, pause the video. Do it! There comes Mr. Lawrence's answer. It's going to be x to the 8th. There you go. So you're learning stuff. The algebra kids haven't learned this yet. Now you're actually ahead of the algebra students. Okay, now here I'm going to throw a couple weird ones at you. This one's a little different. It's 2 squared cubed. Well, this 3 right here means there's 3 of these guys, right? So I'm going to think about this as 2 squared times 2 squared times 2 squared. Hey, look, my bases are the same. 2, 2, and 2. So I can add my exponents. So this must be 2 to the power of 6. Where did I get the 6 from? 2 plus 2 plus 2 is 6. Look at this one. I've got 3 to the 3rd squared. Well, that would be 3 to the 3rd times 3 to the 3rd. My bases are the same. What do I do with my exponents? Shout it, class. You add them. And there you go. You know, if I wanted to figure these out, I could, but that's the answer in exponential form. I could do 2 times 2 is 4, right? 2 to first, then 4, then 8, 16, 32, and 64. 2 to the 6 must be 64. Okay, 3 to the 6. 3 times 3 times 3 times 3 times 3 times 3. And I know that's 9. And I know that's 9. And I know that's 9. So 3 to the 6 is really 9 cubed in disguise. And since I've been memorizing my perfect cubes, I know that the answer is 729. Yeah, there we go. All right, so I want you to try this one on your own. X to the 4th squared. Write out what it really means and see if you can figure it out. Pause the video. Okay, here comes my solution. It means there's 2 x to the 4th being multiplied. And since the bases are the same, I can add the exponents. Dun, dun, dun. Come down here. Look at this. Ooh, how about that one? Hey, you know what? I'm kind of lazy. I know some of you are too. You're good at math, but you're lazy. You don't want to write everything out. Carly, I'll bet you thought I was going to forget about you. Yeah, so did you, Jessica. I'm not going to forget. How can I forget about you two? Come on. Okay. I'll bet you could make up a rule about a power raised to a power. When a power is raised to a power. When a power is raised to a power. Do you see that? Can you see what's happening? Let me highlight them here for you. Let's see if you can figure this out. Okay, so I've got a power raised to a power, and I got 6. I got a power raised to a power, and I got 6. I got a power raised to a power, and I got 8. So when I have this power raised to a power, what do you think I'm going to get? Well, I'll tell you, my base is going to be x. And my exponent, did you say 30? If you did, you're correct. Yes, there's another rule we need to write down. Let me get it over here. Oh. When a power, what, a poser, a power, not a poser. What are you, a poser? Oh no, I'm writing in red. I'm not trying to write in red. Hold on a second here. When a power is raised to a power, multiply the powers. Keep the base. Yeah, that's copying a famous line from a movie, but I changed it. Anyway, when a power is raised to a power, multiply the powers and keep the base. So for example, if I had, say, let's see here, let's go with trapezoid to the 7th power raised to the 4th power. I have a power raised to a power, so I'm going to keep the base, right? Keep the base. And I'm going to multiply the powers. 7 times 4, 28. How about x to the 30th raised to the 4th? Well, keep the base. 30 times 4, 120. I am awesome. This stuff is really pretty simple. It just takes a little practice is all. Okay, so let's see here. Let me see. What else do we have up our sleeve for you? Oh, look at these dandy doodles. Okay, these are actually really easy. I've got 3x to the 5th, I'm rewriting it, right, times 4x to the 2nd. Okay, first thing I'm going to do, let me show you what I'm going to do here. I'm going to multiply. I'm going to multiply 3 times 4. Yeah, I'm going to multiply 3 times 4. And I'll bet all of you can tell me that 3 times 4 is 752. No, just kidding. Sorry. 3 times 4 is 12, right? Well, now I multiplied those Now I got to multiply the x's. I got to do x to the 5th times an x squared. So when I multiply x to the 5th times x squared, I'm going to get x to the 7th power. X to the 7th power. There you go. That's what that equals. 12x to the 7th. All I did was multiply the coefficients, then I multiplied the x's, and I am a happy camper because I'm feeling smart and I'm done. All right, let's try this one. Let's try this one. Oh, wait, you try it. Pause the video. Try it on your own. All right, here comes my solution. I'm going to multiply the 5 times the 7, and then I'm going to multiply the x to the 6th times the x cubed. All right, so 5 times 7 is 35. X to the 6th times x cubed is x to the 9th. The bases are the same. I can add the exponents. All right, I think I've got one more example for you. So let's see that one. Oh, no, there's more than one. They're ugly. Oh my gosh, what am I going to do? Don't sweat it. Don't sweat it. Since these exponents are so small, I can either follow the rule I told you about before, or I can write it out 3 times. So I can say this is the same as 2x to the 5th times 2x to the 5th times 2x to the 5th. Well, to get my answer, I'm just going to get my highlighter out here, don't mind me, and I'm going to multiply 2 times 2 times 2, and if you think that's 6, please get down and do 6 push-ups, because we all know 2 times 2 times 2 is 8, right? Okay, so let's come over here, and let's do x to the 5th times x to the 5th times x to the 5th, and since all the bases are the same, you will get x to the 15th, because all you have to do is add those exponents, the 5 plus 5 plus 5. All right, I want you to try this last one on your own. This is the last one. Try it on your own, pause the video, and then watch my solution. All right, here we go. So, I think I'm going to rewrite that. Have you done the problem yet? Mason, did you do this problem yet? All right, I'm going to write 3x to the 6th, y to the 4th, and I'm going to multiply it by 3x to the 6th, y to the 4th, and 3x to the 6th, y to the 4th. And then Marissa, yeah, you thought I forgot about you, Marissa. I didn't. That's going to equal, let me see here. Let me get my highlighter out. And I'm going to do 3 times 3 times 3, which of course is 27, right? Okay, and then Marissa's going to tell me what to do with these x's. I'm going to do x to the 6th times x to the 6th times x to the 6th. And I know, Marissa, you know that that's going to be, what'd you say? Yes, you're right, Marissa. It's x to the 18th, because 6 plus 6 plus 6 is 18. And then finally, the last part of it, and then I will be done with this problem, I have to do y to the 4th times y to the 4th times y to the 4th, and that is going to equal y to the 12th. There we go. All right, that's it for the video. I need you to be, if you need to rewatch it, you can, but now you go ahead and get started on digits. All right, Mr. Lawrence signing off. Have a good night, everybody.